Alright, so we're going to dive into inequalities, and this will be, we'll do inequalities today and we'll do system inequalities tomorrow, and that will be the end of this semester. So an inequality is, so let's think back to when we did linear lines. So, well, that was terrible, by the way, but either way, we have this line. That's a linear line. We've graphed y equals mx plus b. We've gone through and looked at those. Now, the difference with an inequality is the fact that you're going to start shading. So I'm going to switch kind of colors on here. Yeah, I'll just pick this color. Okay, so an inequality, instead of just being a line, it would be shaded in a certain direction. Okay, so let's say shading above or below. So we're going to start having these greater than or less than or equal to, greater than or equal to kind of signs. Okay. All right. So let's start getting into some of the things that we need to know for these. Then we'll start practicing graphing just basic equations to them. Okay, so I'm going to clear the screen off. So one of the first things that we're going to have to deal with is realizing whether we're going to make a straight line or a dashed line. If your equation has a less than or a greater than sign, so there's no dash on, or there's no line underneath it, that's going to be a dashed line. Okay, so for example, instead of drawing a straight line, we're going to have a dash. If you have a less than or equal to or a greater than or equal to, we're going to have a solid line. Okay, and an example of each of these, the solid line would be kind of like what you've seen before. When we've gone through and graphed things, there's our line. Now a dashed line, sorry, it's going to be just like it sounds. When you draw it, it's actually going to end up being a dashed line. The other part that we have to be careful necessarily when we're shading. And I'll show you multiple ways of doing this. But if you are dealing with a less than or equal to in your equation, you're going to shade down. Okay, and this applies if our y value is first. That's why I'm going to show you a couple different ways to do this. If you're dealing with a greater than or a greater than or equal to, you're going to shade up. So no matter if my line is facing down or up, I'm going to do that for both of these. I'll get my color back out. Again, if it's a less than or equal to, if you have a linear line that's shading down, be below, or if it has a positive slope, we would also be shading below. Those are all less than type of things. So for example, if we had something like y is less than 3x plus 1, okay, those would be examples of where we would shade down. If you're dealing with a greater than or equal to, these are the ones where you're going to be shading above the lines, okay, whether it has a positive or a negative slope. Okay, so if you need anything from the screen, go ahead and get it. We're going to go through and just do some very basic types of equations for these. Okay, so we're going to start off with very, very easy ones. Let's say we have y is less than or equal to 2x minus 3. Okay, so I'm going to go through, hold on real quick, I'm going to change that. I'm going to change my background on here. Okay, so that'd be a little bit easier as we go through and graph this. Okay, so there's my y-axis, there's my x-axis. Now, just like before when we started graphing linear lines, you're going to be looking right here. That is your y-intercept. That's where you're going to cross your y-axis. So we know that we're going to cross our y-axis at -3. Okay, even though my finger didn't land in the right spot exactly, but there's -3. Now, in this one, I have a slope of 2. So that slope in this case, let's see, my slope is 2 or 2 over 1. A lot of you guys use the graph to do your slope. So it basically means that we're going to rise 2. So from this y-intercept to -3, we're going to rise 2, and then we're going to run 3. Okay, so it's going to put me over here. I'm going to take those off there. My finger was dragging, sorry. Okay, so I know that I crossed my y-axis at -3. I know I'm going to go, for my slope, I'm going to, I completely put that in the wrong spot. Okay, should almost start over. It's been a long day. Okay, so we're going to start again. There's my y-intercept's at -3, so we'll cross my y-axis at -3. My slope is 2, or 2 over 1. So I'm going to rise 2 and run 1. I have no idea why I ran that many the last time. So I plotted my y-intercept. I used my slope to find the next point. Now, this is where we have to go through and look at our sign necessarily for it. Okay, so we have to look at this sign right here. We have to determine whether we're dealing with a dash or a solid. Well, if you look back on the previous stuff, if it has that line underneath there, it's a solid line. So it looks something like this. Now, since our y value is first, we can do the shading up and shading down. So if your y value is first, this is a less than, so I know that I'm going to be shading downward. Okay. Oops. If I can remember which button I have highlighted would be great. So we're going to be shading this direction to it. Okay. That's going to be off into this direction. It's going to shading down. Now, another way that you can figure out the direction of shading is you can also test out the point 0, 0. Basically, in your equation, or inequality, if we plug in 0 in for x and 0 in for y, so plug in 0 for x and 0 for y. 0 is less than 2 times 0 minus 3. 0 is less than, in this case that would give me -3. And you test out that inequality, and if it's true, you're going to shade towards 0, 0 on my graph. Well, 0, 0 on my graph is right here. Okay, so what you want to do with that is, if it is true, then you shade toward that direction. If it's not, like ours is not, 0 is not less than -3. We shade away from it. So in this case, as you can tell, we shaded off to the kind of downward left, or downward right sort of region. Okay, so this is an example of an inequality. Now, on your exam, just like in your homework, you're not going to have to go through and hand draw these things. You're going to be given an equation and you have to match the graph to it. So whether you're dealing with dashed or solid becomes very, very important, as well as the direction in which that you are shading. All right, so I'm going to clear the screen. We're going to look at another example. All right, so let's say I have y, we'll do greater than -3x, plus 1. Okay, so again, let's get our x and our y-axis. All right, so I know I have a y-intercept of 1, so I'm going to cross my y-axis at 1. So there's my y-axis. Now in this one, I have a slope of -3, which is the same thing as -3 over 1. So from my y-intercept line, I'm going to go down 3 and over 1. So if I go down 1, 2, 3, and over 1, that's going to put me right there. So now I have to look at my sign and determine if I'm dealing with a dashed or a solid. That does not have the line underneath there, so when I draw this line, it should be dashed. Try to draw the dashed line the best that I can. Actually, when I'm drawing with my finger, it doesn't come out very nicely. Let's see if I can make that a little bit. I don't know if that's any better, but it should be a dashed line. Okay, so now this point, for instance, it's a little bit harder to tell with 0, 0. For one, because of my terrible drawing, but 0, 0 is actually kind of off to the left. So I can go through and I can test out that point 0, 0. So y greater than -3x plus 1. If I plug in 0 for y, and I plug in 0 for x, I want to see if this thing comes out true. So is 0 greater than 1? No. So that means I'm going to shade away from that. Now I can also tell when I looked at my equation, since my y value is first and I'm dealing with a greater than symbol, that I would have shaded, I forgot which one I was on again. We're going to shade above. So it's going to be shaded in this direction. Now, some of the stuff that you guys are going to deal with are already going to be in y equals mx plus b form. Be honest with you, most of the system, especially inequality stuff that you're going to deal with on the Math 1 exam, excuse me, are not going to be in standard form. You're going to have to get them into y equals form. So we're going to do a couple examples of those. So if you need anything from this one, go ahead and get it. All right, so we're going to try, let's try 4, again, I forgot which one I'm dealing with, there we go. So let's try 4x plus 2y is less than, I don't know, 8. Okay, well, I got some nice easy numbers to work with. Well, in order to see my slope and my y-intercept, I'm going to have to get this thing into slope-intercept form. So I'm going to have to move the x term first. So I get 2y is less than negative 4x plus 8, because I usually try to write the slope term first or the x term first. Then I went ahead and divide by 2. So I get y is less than negative 2x plus 4. So now I can see my slope, now I can see my y-intercept. I could go through and I could graph this. So there's my x and my y-axis. I know I have a y-intercept of 4. So there's my y-intercept. I have a slope of negative 2, so that means I need to go down 2 and over 1. So put me right there. And when I look at this sign, I am dealing with a less than, so that means I'm going to be dealing with a dashed line. So I'm going to try to draw this dashed line the best that I can. Okay, that was terrible, but it'll have to work. Alright, so there's my equation. Now, again, since my y value is first, and it is a less than, I know that I'm going to be shading down. So it looks something like this. You could also go through and test out your point and see if, if it would go through 0, 0. Again, if I test out 0, 0, plug in 0 in for y, and I plug in 0 in for x, and I just solve. Is 0 less than 4? Yes, it is. And if you notice with our orange shading, we actually shaded towards 0, 0 for that one. So that's the reason we went towards 0, 0. Now, if you think back to when we did linear equations, you actually could have gone through and graphed this one without getting it in y equals. Do you remember going through and finding your x-intercepts and your y-intercepts? So I'm going to erase some of this work off of here so that you can see that. So give me just a second. I'm going to erase some of this stuff off. If you need it, pause the video. Okay, so I'm going to get rid of some of this stuff real quick. And to show you another term. I mean, we learn these things, such as different ways of graphing linear lines. You have all these tools at your disposal. You can use what you need to. You don't have to just stick necessarily to one way. And this is a good or an easy example of finding your x-intercepts and your y-intercepts. You could have graphed it this way too. It's in standard form. So when we had things in standard form, it was oftentimes easier for us to graph it by using or finding our x and our y-intercepts. So to find my x-intercept, if I covered up the y term, that would have left me with 4x less than 8. I would have had to divide by 4 to both sides. So I get x is less than 2. And look, I crossed my x-axis at 2. And now, with this one, to find my y-intercept, I would have covered up the x term, so that gives me 2y is less than 8. Again, I would have divided by 2. And 8 divided by 2 gives me 4, and voila, we actually crossed our y-axis at 4 as well. And because of the fact that the y value is on the left, in this case, because this dashed line technically represents 8, it's a less than that, so we shaded down below. So it's just kind of another option, especially if you forget how to get things in y equals, or you're really struggling getting things in y equals. You can go back to looking at your standard form too. Alright, so I'm going to clear the screen off. There's something else that we need to talk about real quick before you start looking at these. So if you need anything from the screen, go ahead and get it. I'm going to pause, or I'm going to clear the screen. Okay. So one of the other things that we have to be careful of is, let's say I had something like 2x minus 3y is, let's say, greater than 3. Or sorry, let me pick a better number. Greater than 6, let's say. Well, we would go through, especially if you're getting this thing in y equals, kind of similar to what we did before, we would have to move the x term over. So I get negative 3y is greater than negative 2x plus 6. I would have had to divide by negative 3. And this right here is where you need to go through and put some sort of a star, asterisk, whatever it is that you need to do. If, okay, it doesn't even look like the word if, but if you divide by a negative number, you are going to have to flip the sign. Okay? So this is kind of something that happens every once in a while when you go through and solve linear inequalities, because it's not an equal sign, it's an inequality. So if you, sorry, we talked about this briefly when we solved inequalities earlier in the semester. But in this case, since I am dividing by a negative number in order to get my y value by itself, okay, negative 3 divided by 3, I have to flip my sign. So it's to be a greater than, I have to flip it. So this is just something that you're going to have to make sure that you're careful of. So this would be 2/3 x minus 2. Just make sure that it's going to pop up on a couple of your homework. So if you need to go through and just put an asterisk, a sign, whatever it is that you need to do. But you have 2 of them that were already in slope-intercept form that you have to match. And then the rest of them are, most of them are in standard form, and you're trying to get them into y equals, because that's generally what you'll see at the exam. So again, if you need any help with anything, just let me know.